Teacher knowledge and behavior is the component of the model that focuses on teachers' knowledge of students and content and on their expertise in classroom management and pedagogy. Teacher knowledge is the element of teacher knowledge and behavior that encompasses knowledge of student characteristics and teachers' in-depth content knowledge and the blending of these to enhance learning. More information on this can be found in the Technology as Facilitator of Quality Education model. The students in this 8th grade science class are learning about the properties of sound. The teacher displays comprehension of the subject matter by communicating the goals and objectives of the unit clearly. This demonstrates the teacher's in-depth content knowledge.
Ms. Chernin is here, and what she's going to do is introduce you to Artemis, which is the program. And the next question that we're going to be answering in order to complete our sound unit to get you ready in order to design your own experiments is, now that we know how sound is produced, all right, what it takes, how do we vary the dimensions of pitch and amplitude, then what we're going to do now is how does sound travel, okay? And what we're going to do is do some information. Jan will take you through a process, and then you'll go on to the computers, work on Artemis, and you're going to take notes, and then we're going to come back and generate the notes on the board for everybody. Then what we'll do is we're going to use that information to go into a program which is called Sound Edit, okay? And we'll talk more about that a little bit later, okay?
Another component of the teacher's in-depth content knowledge is evident in the method of instruction. Instead of lecturing, the teacher uses discovery learning to engage her students. She has a media specialist introduce the students to the Artemis Digital Library, a collection of websites cataloged by the University of Michigan. The students use Artemis to search for information on sound waves.
I mean, here's a thought for an experiment for you, if you're thinking of something like that. Now if that intrigues you, there are experiments that you can design to see. And you can try testing sound as it moves through the air, and then take the same thing and take that frequency and move it through liquid, and we have things to set up there, and then through a solid, and see what you notice, okay? And the gas would be just as we do it right here, okay? You wouldn't take someone's word for it. You would want to see if they're right or not, right? So that could be a suggestion you might want to tuck away. And by searching through these things, you'll come up with many other ideas based on what intrigues you with the information you find. And that's part of the reason why you also do these searches.
The teacher displays knowledge of student characteristics by giving her students opportunities to use their interpersonal intelligence. The students search through the Artemis Digital Library in groups of 2 or 3, working cooperatively to sift through the information they find. The students collaborate to determine which pieces of information are relevant to their search.
Go for physical science search.
It doesn't really matter. It's pretty much the same thing.
We got to that site for biology.
You got to that same site for biology? Okay.
What is it again? Just scroll down here. Oh, Chris.
And then, all right, you got it.
Hey, did you guys get this?
Kenny went to not my friend.
Yeah, what is that?
How to work like burners and whatnot. Okay, we got the exact same thing.
No, maybe you might want to go back.
Believe it or not, it's not different. Mrs. Gleason, the difference is sound waves.
The teacher again shows knowledge of student characteristics by encouraging her students to use their visual spatial intelligence. During a class discussion about different kinds of sound waves, a student draws a picture of a transitional wave on the board. This helps his classmates visualize the way sound is measured.
What would you say on an oscilloscope? Okay, can you make a nice big wave?
Yeah, I'm making this big for us, Chris.
Okay, well, all right, not bad.
It wouldn't be.
And what kind of a wave is this, Chris?
But it looks like.
Is it a transitional wave or longitudinal?
It looks transitional.
Okay, so this here is a transitional wave, okay? See if we can get this marker to work any better. There we go. Okay.
The teacher uses questioning as a method of instruction during the class discussion of sound waves. She asks specific questions about how sound travels in order to stimulate the students' thinking and in order to help them express their thoughts more clearly. This demonstrates another component of the teacher's in-depth content knowledge.
And sound is actually traveling from here to here. But in order to get there, it has to move all these molecules. So when it bumps into molecules, it's a compression, right? And then as it moves on to the next set of molecules, this expands, right? So molecules move like this, okay? The molecules compress together, they expand, and then it hits another group and expands, so that all the molecules from here to there get hit with the energy in order to hear that sound. Now, is it just like one line of molecules like this?
No.
No? So how many molecules would you imagine would be able to be affected this way?
Millions. Depends on how loud the sound is.
So, I mean, is it just going to be this small? I mean, like this? The size of my mouth?
In a half circle.
It expands.
Yeah.
And what would allow it to expand?
The air.
The air and also what?
Volume.
The amplitude.
All right. Probably the amplitude, right? All right. Because it allows, and does sound then, the minute I don't hear it anymore, does sound go away?
There's friction in the air, so eventually the force is going to diminish.
Okay. Eventually the force is going to
Theoretically, in space, the sound would travel forever.
Or never, because there's nothing to
That's
transmit
true.
to.
In space. Very good question. Would there be sound?
No, there's nothing for
But if there were sound, it would travel forever.
Because there are no molecules for it to bounce off.